Let's talk about what we call the standard form. So for today's class, we are going to be talking about, or for today, we're going to be talking about what we call standard form. Standard form. Standard form. Standard form is one of the most important topics we have in mathematics. And what does this standard form mean now? Standard form means expressing number in a scientific form. So whenever we express number in scientific form, we call it standard form. So expressing, we talk about expressing, we are going to be saying something about expressing numbers in scientific form. So in this video, I will show you how to express number in scientific form. So the way I'm going to explain this is I am not going to explain it like your regular teacher or the way you are being taught in school. I'm going to give you hints or information that you need to keep checking out, or you need to keep checking on or keep checking out whenever you see numbers or whenever you see standard forms, so that you get a maximum result. So without wasting much time, if you are new to this channel, don't forget to subscribe and click on notification bell icon to know when I upload a new video. So without wasting much of your time, let's get started. Now, when you talk about the standard form, what does this standard form mean now? I just say that standard form just simply means expressing numbers in what you call scientific form. Or scientific form. And what do I mean by expressing numbers in scientific form? Let me show you how I mean by that now. It just simply means that you are to have what we call, this is what we call a standard form. You are to express number in this way. So whereby this is what you call your numbers. This, your A, can be any of this number. It can be 1, it can be 2, it can be 3, it can be 4, 5, 6, 7, 8 or 9. So it just simply means that this number can never be 0. Please take note of that. Listen carefully to what I am saying. I just say that this number can never be what? 0. Rather, this number must be what? Either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Any of these. Whereas that this expression known as your n is just an integer. And this your integer could be a positive integer or a negative integer. So it could be what? Positive integer, or it could be what? Negative integer. And please, what do I mean by that? How I mean is this, that this just simply means integer just simply means your number. And numbers can be 1, it can be 2, the integer can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It can be something like this. Sorry, not 10. Sorry. I didn't mean 10. 9. Then it can also be minus 1, minus 2, minus 3, minus 4, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. It can be any of these. Pay attention. What did I call this one? I call this one positive integer. These are the positive integers. So it means that our n can be any of this number, or our n can also be any of this number known as our negative integer. You will now pay attention, or you will now observe that our n can never be 0 no 0 included. So your n can never be what? Any of those things. So this your power that we're going to have can be any of these. So that's it. All right. So if you have understood this now, I am going to give you one secret that you need to know, or you keep looking out for whenever you want to solve question under standard form. And what is that now? What you're going to look at for is one thing now. Since I've already told you that it just simply means you express this number in a scientific form, and which is this way. What do you need to take note of now? You need to take note of one thing. This point, this is what I want to take note of now. Now, if you're moving the point, we are talking about points. I'll be explaining what we call points moving. Points moving. I'll be talking about points moving. This is what I want to take note of now. If you're moving the point from fronts, okay, from fronts, where the number is or where the point is, to back, fronts to back, please, it's the n, the n or n will be what? Will be negative. It will be negative. So your n must be negative. Okay, so another point you need to take note of is from, if you're moving from okay, from back to front, your n will be what? Will be positive. N will be what? Positive. So that is exactly what I want you to understand or know. So you might be wondering, how do I mean? This I am about to explain now is going to be applicable to in two ways. Anyway, just take note of this point. So it is either, first of all, what you expected to know is, I'll be explaining two things now, how to convert or how to express numbers, I'll be talking about how to express numbers, just numbers to standard form, So this is one of the things that I'm going to do. Then another one is I'm going to talk about to express what you call what now standard form. Okay, standard form to what? To your numbers. So these are the two things I'm going to be covering in this our course of learning. So please, if I'm explaining this now, I need you to pay attention very well and understand how this is very important, is being done. Now, the essence of it is you are going to be seeing standard form aside your mathematics. You are going to see that a lot in your physics, especially like topics like gravitational field and so on. Gravitational field, electric field, where you'll be dealing with what we call standard form. So if you do not understand this standard form now, you might find it difficult to solve some questions in your physics under standard form. So pay attention. So let's go over to the next thing now. Let's start from the first one now. How do we express numbers to standard form? I'm going to start from that. And I'm going to apply this same rule that I wrote here in anything that I'm doing. In fact, every calculation that I will be doing, I must be applying this rule so that you see how it is being done. So let's start from the first one now. Expressing numbers to standard form. Okay, let's say we have a number like this now. Let's say we have question one, express. We have express 400, express for to standard form. Assuming you are given something like this is the first question, and second question says 0.004 to standard form. How do I express both of them to standard form? Let's start from the first one. So for the first one, you are going to do something. So let's start from the first one. I have my solution. The first one says we should 4,000 to standard form. So how do I express 4,000 to standard form? First thing first, you need to locate your point before you start moving it. What did I say? You need to locate your point before you start moving it. And where is my point? If I look at this and I discover that there is no point in between, so I will now know or take note that my point is what? At the back. So this point is at the back. And the rule of standard form says you are to express only a number times 10 raised to the power what? Your n. So it means that we don't need all these numbers. The only number that we need is only one number, according to the rule, only one number, which could be 1, it could be 2, it could be 3, it could be 4, it could be any number, just only one number. That's the only thing that we need for this standard form. So for that reason, where is my point? My point is behind or at the back. I need to move my point from back to front. And what did I say now? From back to front, what is it now? The standard form, your n will be what? Will be positive. Take note of that. From back to front, your n will be what? Positive. Now let me show you what I mean. Now this is my point here, and I start moving it. 1, 2, 3. I moved it how many times now? 3 times. So I'll write 4 points. I can write 4.0, 4.0. Okay, you know, this is my expression. This is my A already written. And I'll say times. 10 raised to the power. 10 raised to the power, what do we have here now? And I now say that my n is going to be what? My n will be what? Positive. So since I moved it 3 times, my n will be what? Positive. And that is going to be my final answer to this question. So this is how to solve this question. So let's consider the second one. The second question says 0.004, okay, to standard form. If I am to express this one to standard form, so how do I express this into standard form? This is very simple. I'll still do the same thing now. First thing first, you need to locate your point. Remember, the rule says first thing first, locate your point. Locate where your point is before you start talking about moving it. And if you locate your point, take note of that. Locate your points before you start talking about moving it. And how do we move it? You either move it from what? From front to back or from back to front. Where is our point here? Please, where is our point? Our point is located here. And how do we move it now? According to the rule of standard form now, standard form simply means that you are to write only a number, and 0 is not included in the numbers that I have. If not, I would have said let's stop at 0. But 0 is not among the numbers that are listed out that must be here. The numbers that must be here must be what? Either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So because of that, I am going to move this point to in front of this number, in front of this number. So I'm going to say from front. So I'm going to move it from this front to this back. So how do I move it now? I'm going to move it 1, 2, 3. So I have it as 4 points. 4 points. I can add 0 to just complete it. I can add 0 by say 4.0. 4.0 and 4 are the same thing. Then I'll now say times 10 raised to the power. 10 raised to the power what? This is my n. We have, since I moved from front to back, from front to back, this my n will be what? Will be negative. So I'll just say minus 3. And that is how to express that. Very simple to understand. Very easy to solve. Let's consider other ones now. Let's consider other part of it now. Let's consider some other expression. So let's consider other expression now. You are giving something like express as standard form. As standard what? As standard form. The first question says we have it as 1, 2, 6, 7, 1, 2, 6, 7, 1, 2, 3, 1, 2, 3. The second question says 0.000, okay, 0.0000156. Okay, so these are your two questions that you are given to solve. So how do we solve this question? Now let's consider this question altogether. Remember, what's the first point? What is the first thing that you're going to do? Take note of that. The first thing I'm going to do is locate my points. Where is my point? Look at this. I'm not seeing any point here. So I know that my point is at the back. So since the point is at the back for the first question, since the point is at the back, what do? I'm going to move it from back to what? Front. Please, why am I moving it from back to front? Because according to the rule says that the number that we're going to have here, must be either of this, pay attention. It must be either of this 1, 2, 3, 4, 5, 6, 7, 8, 9. Just single of this number. Any of this number, not the whole numbers. Pay attention. What did I say? It is going to be either of this number, not the whole numbers. So if you look at this number that we have here, which of the numbers do you think we're going to have here as our standard form? Look at it. It's only this one. We don't need all these ones. So it's going to start from this one. It's going to start from here, maybe here and here. So we don't need other numbers that was going to be included. So that is it. So for that reason, what do we do now? We are going to move this point from where? From back. 1, 2, 3, 4, 5, 6, 7, 8, 9. From back to front. What did I say? So I have it here. The point is now here. So I will now say I can say 1.2. 1.2 because the point is between 1 and 2 because the rule says that it must start from any of these whole numbers. It must start from any of these whole numbers. It must start from any of these whole numbers and not from 0. So since it started from 1, I have it as 1 point there. The next number, which is 2, then I will now start times 10 raised to the power. The power is going to be what? Is it going to be positive or is it going to be negative? Since I move from back to front, what did I say that it's going to be? It is going to be what? Positive. How many times did we move? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved 9 times. So we have to have it as what? As 9. Okay. So look at the second question. The second question, where are we going to stop at? I hope you now understood what I'm doing. So remember that the numbers can be any of these numbers. So the number we're targeting is here. So we need to move these points to here, between this 1 and this 5. So we're going to move it. We have it as 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So I have it as 1 point. I have it as 1 point. I can say 1.56, which is the only number remaining, times 10 raised to the power. I moved it 9 times. And from moving point from front to back is going to be what? Negative. I will now say 9. 9 because I moved it 9 times. And this is going to be your answer. That is all. All in standard form. That is all. Okay, now, since I've already explained this now, how do we think about this now? Let's just say, before I proceed, let's just say, assuming we are given something in standard form and we expected to convert it from standard form to ordinary numbers, from standard form to numbers. So what if we are to convert from standard form to numbers? How do you convert that now? Let's take, for instance, I have it as 4.0. Remember, 4.0 times 10 to the power of 3. And I want to convert it from standard form to numbers. You see that what we have here, what do we have here now? We have these dots, these points, these are dot points here after a number, but we want to remove it, which means that if you want to remove it now, this point is not going to be here. We need to send it to the back. We need to remove it from these numbers totally. So if you look at this now, if I am to move these points so that it will, because if I move it here, it's going to stay, this point is still going to be in front of a number. It's going to still be in front of a number. But we want this point to be behind, like very far away behind, not in front of any number, just it's going to be at the last number. It's going to be the last thing you are going to see. We don't want to see a number after it. That is how to move it. So because of that, because I want us to move this point to the last part, whereby we're not going to see any number after it. So what do I do now? I'm going to do it this way. I'm going to say from these points to back, like from front to back. From front to back, what did I say that front to back is going to be? Front to back is going to be what? Negative. So it simply means what now? I will just say 4. See, how many times am I going to move it? 3 times. So I'll just say 1, 2, 3. Like I'm going to say 1, 2, 3. I move it 3 times. This is my point. I'll put 0 here, I'll put 0 here, and I'll put 0 here. Because I move it 3 times, I'll say times 6 to the power minus 3. I moved it 3 times from front to back. So since I move from front to back, I'll say minus 3. So this is going to be times 10 to the power what? 3. Remember, 10 to the power 3 is there already. So what is going to be my final answer? I will say 4,000 times 10 to the power minus 3 plus 3 is going to give me 0. So I have it as 4,000 times 10 to the power what? 0. And this is 4,000 is going to be your final answer. Why? Because 10 to the power 0 is going to give me what? It's going to give me 1. It's going to give me 1. And 1 times 4,000 is what? 4,000. However, if you do not prefer this method, probably do not understand this method, you can still go with your other method, which is 4.0 times 10 to the power 3 means 10 times 10 times 10. And when you multiply this in out, it's still going to give me what? 4,000. This is another way to solve it if you don't want to do that now. Or, better still, you can still go with another method by saying 4.0, just 4 points, just add 0, 0, 0, just add 3 zeros. It just simply means another method. Or you can say 4.0 because it is positive, you just add 3 zeros in front. But if it is negative, you add 3 zeros in front. So that is another method that you say you can use. How many methods did I list now? I listed 3 methods. I showed you how to solve and you got this. Please, if you do not understand, take this video back and you understand it. I also said that you can also do 4.0 times 10 to the power 3, which is 10 times 10 times 10. You can also do this something like this. That's the second one. And the last thing that I said is that you can also, because of time factor, if you're very fast enough, you don't want to waste your time, you can also just say, since this is positive, it just simply means add how many zeros now? Add 3 zeros in front, or just move it 3 times positive. Just move it 3 times, and that is exactly what it means. All right. So now let's say, assuming we have something like this. Let's say we have we have something like 0.00, sorry, we have something like 4.0 times 10 to the power minus 3. And I want to take it back to ordinary number, not in standard form. How do I do now? Well, because it is negative, let me not apply my rule here, that rule that I told you. Let's apply another rule. So because it is negative, I can just move it like 1, 2, 3. So which is this point is here. I can now say 0, 0, 0. So it's going to be 0.004. This is my answer. If you want to go with this method, you can move it directly. So this is the way. So I've now explained to you now that if you want to convert, another way is if you want to convert from standard form to ordinary number, so you can move. I just say that 4.0 times 10 to the power 3, because it is positive, you just move it 1, like you say 1, 1, 2, 3. You say 1, 2, 3. That's what it means. Okay, that's for this one. Or the second one says you have 4.0 times 10 to the power minus 3. What does it mean? Minus, because it's minus, you are going to move. This is to the right. You're going to move to the left. 1, 2, 3. So you put 1, 2. You put 2 zeros and put 0 in front of this place. So you're going to have 0.004. Now this last 0, you can include it, you can leave it. So just leave it this way. And that is your answer that you are going to get. All right, quickly, let's talk about what you call operations. Let's talk about what you call operation in standard form. Let's consider what you call operation in standard form. And when I say operation in standard form, what are the operations? The operations in standard form include what we call the positive operation. What another expression do we have? The operation negative multiplication and what division. So these are the operations in standard forms that we have. So let's start with the first one. Let's start with how do we add standard form? Let's start with what we call addition. So how do we add addition? Let's start with addition. How do we add addition? Addition and subtraction have the same rule. Addition and subtraction, they have the same rule. Addition and subtraction. How do we add in standard form? And how do we subtract in standard form? Let me just show you how to do that now. Assuming you have something like, you have example 1, you have 6.03 times 10 to the power what? 6 plus 2.17 times 10 to the power what? 10 to the power 5. And you're asked to leave it in standard form. You have to leave it in standard form. So how do you leave this in standard form? This is very simple to solve. First thing first, before you can add this kind of number or before you can subtract this kind of number, make sure that both standard forms are the same thing. Please take note of that. What did I just say? I say that make sure that both standard forms are the same. There are many ways to make sure that both of them are the same. It just simply means that either this one is 10 to the power 6 and this one is also 10 to the power 6, or this one is 10 to the power 5 and this one is also 10 to the power 5. But let me not stress you with all those protocols. The only thing I'll just tell you is this now. There are many ways to solve it. But let's start with the first one. I can just say 6.03 times 10 to the power 6 plus 2.17 times 10 to the power 5. Then I'll now talk about common factor. What is the common factor? Common factor that we have here now. Our common factor is 10 to the power 5. If you cancel one of the 10 to the power 5, this one has gone. Then if you cancel this now, what are we going to have here? Remember that 10 to the power 5, when you cancel with this one, it's going to give you 1 here. But this 10 to the power 5, when you cancel 10 to the power 6, it's going to be 10 to the power 1. So I'm going to have 6.0 times 10 to the power 1. Because we have, how many 5 do we have inside this 6? We have 5. Only 1 is going to remain. So, okay, plus 2.17. Okay, that's all that we have. We have 10 to the power 5. So we have gotten our common factor this way. This is one of the ways that you can use to solve the question. So what next am I going to do? I can just multiply these two numbers together. When I multiply these two numbers together, it's going to give me 60.3, okay, plus 2.17. Okay, 10 to the power what? Times 10 to the power, I can just say times 10 to the power what? I can put times 10 to the power what? 5. At this point, you cannot add. You cannot add both of them together. When you add both of them together, I'm going to have it as 60.3 plus 2.17, and that is going to give me 62.47. 62.47 times 10 to the power what? 5. Should I leave my answer this way? No, I can't leave my answer this way. Why? Because the point is supposed to be after a number. You know, when I listed the numbers, I listed that the numbers could be 1 after a number 1, 2, 3. I never said that the number is going to be after 62. No, after 2 numbers. No, it's going to be after a number. So what am I going to do? I'm going to move my point from back to front. From back to front is going to be what now? From back to front, is it going to be negative or is it going to be positive? Check where I told you that. From back to front, I have it from back to front is going to be what? Yes. What is it going to be? It's going to be what? Positive. So you are going to have it at 6 points. You know, you only moved it once. So have it at 6.247, you know, 247 times 10 to the power 1. Why is it 1? Why 1? Because from back to front is positive. Then you now say times 10 to the power what? 5. So when you must add both of them together, what do we have now? We have it as 10 to the power what? 6. And that is your final answer. I hope you are taking note of all this explanation. All right. So aside this way that I did it, do I have any other way that I can solve it? Remember I told you one thing, that you can make both of them to be the same thing. Now let me see. Let me try another method. Let's try another method. Apart from this that I did, let's try another method. I just said that the rule of this addition says that you must make both of them to be what? To be the same thing. That's the rule. Do you get? I said that both of them must be the same thing. So how do we make both of them to be the same? It is either you make this 10 to the power 6 to be the same thing with 10 to the power 5. Like this place will be 10 to the power 5. And here will be 10 to the power 5. Or you make here to be 10 to the power 6 and here to be 10 to the power 6. So that's what the rule says. But let's make the first one, 5. And how do we make it 5? How do we make it 5? Remember, how do we make it 5? If I move this point from front to back, what did I say is going to be? From front to back, what did I say? The n is going to be what? The n, is it going to be positive or is it going to be negative? Check where I said it. We have moved it once. We have moved it once. And when I move it once, I'm going to have it at 6.3, okay? Times 10 to the power is equal to be minus 1, because from front to back is going to be minus. Then I say 10 to the power what? 6, okay? Plus what? 2.17 times 10 to the power what? 5. All right, so what do we have here? And I'm going to have it as 6.3 times 10 to the power minus 1 plus 6 is the same thing as minus 1 plus 6 is the same thing as saying 6 minus 1. And 6 minus 1 is going to give me 5. So I can just have it here. Here is going to be my 5. Also, I'll just say plus 2.17 times 10 to the power what? 5. So you will now discover that both of them are now the same thing. 10 to the power 5, 10 to the power 5. So since they are now the same thing, I can now choose my common factor. What is my common factor now? 10 to the power 5. I can now add both of them together, which is 60.3 plus what again now? 2.17. I can now add both of them together. If you add both of them together now, you will now see that you are going to get your 62.47 times 10 to the power 5. And when you go with this now, you know, I told you this point cannot be after 2 numbers, rather after a number. So if you move this point from back to front, what is it going to be? From back to front is going to be positive. The n is going to be positive. So this is from back to front is going to be 6.247 times 10 to the power what? 1. Okay, you know, I moved 1 because I moved it once. So times 10 to the power what? 5. This is going to be 6.247 times 10 to the power what? 6. And this is going to be my final answer for this now. So you see that any way you want to move it, like I said, we just made these two to be the same. Like I made this 10 to the power 6 to be the same thing with this one. If I don't work in this way, what other way can I also do it? I'm only showing you the possible ways you can solve this. You can get this now. Assuming you want the other one, which is 10 to the power 5, to be the same thing, what do I do? Let me show you. Assuming I want both of them to be what? The same thing, what do I do? I want both of them to be the same thing, which is I have the question says I have a 6.03 times 10 raised to the power 6 plus 2.17 times 10 raised to the power what? 5. Now, before, the one I did, I made this 10 raised to the power 6 to be the same thing with this 10 raised to the power 5. This time around, I want this 10 raised to the power 5 to be the same thing with 10 raised to the power 6. That's what I want to do now. So how do I go about it now? Remember, what do you do? How do I move my point to get a positive? How do I move my point to get a positive n? Remember what I told you. If you're moving your point from back to front, it's going to be a positive n. So which means I'm going to have 6.03 times 10 raised to the power 6 plus from back to front. So I'm going to have it as 0.217. Okay, from back to front. So I have it as back to front is going to be positive. So I say 0.217 times 10 raised to the power 1. Because I moved it once, I'll put 1. 1. And why did I say positive 1? Positive 1 because I moved from back to front. That's why I say positive 1. Then I'll now bring that this and I say 10 raised to the power 5. So I'll say 6.03 times 10 raised to the power 6 plus 0.217 times 10 raised to the power what? 6. So what do you have now? I have my common factor to be 10 raised to the power 6. 10 raised to the power 6 as my common factor. Then I can now add 6.03 plus 0.217. I can now add both of them together. Very simple to solve. So when I add both of them together, let's see what is going to be. 6.03 plus 0.217. And this is going to give me what? What is it going to give me? 6.247 times 10 raised to the power what? 6. Easy peasy, very simple. They are all giving you the same answer. Any way you solve it, you are going to get the same answer.